So on this part, we shall start by opening our folder. This is the folder. This folder started with us from the first part. So I'm using the same folder for everything so that all the files are in one place. And at the end of the series, I'm likely to post the whole thing on GitHub for everyone to have access to. So I double click to open the folder. So I'm inside the folder now. Click at the top here, CMD. Some of us that started from the second the video would have understood this process. It's a way of getting Python. It's a way of opening your Jupyter notebook without any need to use the window button or whatever. So you are going direct into it, into the folder. So I'm inside that folder now. Now type Jupyter, small letter, Jupyter notebook. So this opens our Jupyter notebook, which is the environment that we shall be using for the whole session. It's coming up. Yeah, it's here now. So this is the environment. It opens by default. It uses Edge to open. So if you have Edge on your computer, it uses that to open. That is the default. That is the default browser for it. That does not mean you cannot run it on Chrome. It's possible. So, as in our usual way, we are doing this is going to be our. I've opened a new Jupyter notebook. So I give it a title. This is session. This is 5 of 20. And this is 5 of 20. This is Python Numpy. Or we call it data analysis part 1, whichever way you want it. So but I want to call it Python Numpy. Python Numpy. Okay, so I rename from the top here. As soon as you rename here, it goes to the folder. Let's go to the folder. As you can see, this is it here. Automatically it changes the way it's stored in the folder. Okay, so we have our environments ready. We are set to crack the whole Python stuff. Now, as mentioned earlier, what is NumPy? What does it mean? Why do we need to use it? NumPy is an open source library. When we talk of library, we're talking of packages. Just like you want to do something, you need a package to make it happen. You want to do some other things, you need another package to make it happen. So in this same way, NumPy is one of the packages in Python, and it happens to be a fundamental or base package to some other packages. Some people call them libraries. They are the same. Either you use library or you use package the same way. So it's an open source and it's a library which is part of Python. It provides support for very large multi-dimensional arrays and matrices. Some of you that went through mathematics here and here and there in those days, you will understand the fact that we did some matrices in those days, no matter how little they were. Python can do these same operations. Instead of you doing all those long calculations, Python makes it happen in just one line of code. Now, for this to happen, you need this package called NumPy. NumPy. It has a lot of mathematical functions in it. You want to sum two things, instead of you saying 2 plus 3 plus 4, whatever, you can just call a sum function. Put everything inside it, it sums and it gives you the answer. You want to do some other manipulations, Python, Numpy allows you to do that. It helps you to get this done. Now, why do you think we need Python? Number one, it is very difficult. It will be very difficult for anyone that wants to perform operations in Python without NumPy. Very difficult unless you don't want to do more data manipulation. So you can hardly be a data analyst or data scientist or AI person without understanding Python. So Python is part of Pandas. Pandas is just like your Excel. That is the Python version of your Excel. So Python Excel cannot exist without figures. The same way Pandas cannot exist without NumPy. We have Matplot library, which is for visualization. This library cannot work properly without your NumPy. We have some other scientific libraries. We call them SciPy. All these libraries is a set of libraries. We call them SciPy. This library called SciPy needs NumPy to run, and it has a lot of functions embedded in it. Then we have another package or library which we use in machine learning. You will agree with me that when we talk of AI today, we are talking about the use of machine learning. We are talking about some element of that data science. So that means you cannot even do AI without understanding NumPy. You can't do data science without understanding NumPy. You can't be a data analyst without understanding NumPy. Now, the last part of what I want to mention today is Scikit-learn. Scikit-learn is a machine learning library that uses NumPy. NumPy to handle data input and build your models. For building your models. Remember, for you to build your models, you need something to get the data, make the data available for you. You need something to be you need something to manipulate your data so that you are able to put them in the right context for machine learning models. So Python is one key stuff for those ones. Now, is there are there advantages of using Python? Why do we have to use it? Why do we need to use NumPy? Does it mean all the operations that we are going to be performing with NumPy, the other packages cannot do it? That is not. Yeah, that is not. Other packages or some other packages can do this. However, the advantages of using NumPy includes the following. Number one, speed and performance. Is very fast. It executes much faster than any other package to perform mathematical operations. And it's just because it has some element of C in it. C language for those of you that understand C. Number two, it is memory efficient. So that means if the memory of your computer is low, that does not mean Python cannot run. It helps. It helps. I've run some operations before that made it so difficult that took over 24 hours to get a result, and my computer ran for that 24 hours for those 24. Why? Because the memory of the computer I was using then was so low compared to the operations that I was performing. Number three, mathematical capabilities. NumPy has that mathematical capability that it can perform that hectic mathematical equation. It can solve it in just one line of code. Number four is integration with other libraries. It integrates easily with all other libraries. Number five, it is convenient. It is very, very convenient to use and easy. And the last reason is that it supports multi-dimensional array. Now, when you talk of matrix, you're talking about your row and your columns. That is two-dimensional arrays. Now, we can have an array that is much more than that, which is, of course, is outside the scope of what we're going to consider. But I'm just saying, for those of us going towards AI, those of us going towards deep learning, those of us going towards um, computer vision, we are likely to, do a lot of multidimensional array manipulations. So this explains why this is very good. It's very, very good. So now let's get cracking. Now for us to go through this, we need to install the package. Our environment is running now. Now, since our environment is running, what do we need to do? And how do we get on to do those things so that we are able to say we have understood everything on NumPy? Now, the first thing is that we are going to install the package, and I'm going to tell us on this call that whatever you want to install in Python, there are two ways to it. The first way is to install it from the environment that you are using. Install directly from that environment. I'm using Python. I'm using Jupyter Notebook. Now, because I'm using Notebook now, all I need to do is to come here and call pip. Pip is one package that is used for your mostly all your installations. There are other packages that can make it happen. It depends on whatever must have been installed on your computer. On this computer, I have conda installed. I have pip installed. So the choice is yours. So you can do pip numpy. I want to install it now. Numpy pip pip install numpy. That's all. So if I run this, because I have it installed on this computer already, you will see the answer now. Let's run this. Takes a little while. You can see this is star now because it's still trying to do. So normally it has to download onto your computer, then install it automatically. So let's see what the response is like. So it's still putting stuff together. So when that is done, if you have an conda installed on your computer, then you can call conda install numpy. That's it, same way. So as you can see the response here, requirement already satisfied because it has been installed on this computer prior to this time. So we are good to go with this. Now the next thing that we want to do is how do we make use of it? That is when we bring in the package into this page. We call it import. So I'm going to import it. Import numpy. But I'm going to import it as np. np means anywhere I want to use it, instead of calling numpy, I'll just be calling np. That's what I want to do now. Import. Right. So anytime we run this and this is star, that means something is going on. As soon as it's done, it gives you a number. Number means that is the how do I call it? It's a serial number based on the operations that you are performing. Now that is it. Now the next thing we want to do is to understand. Let me give this a title, small title. Understanding. We've defined it, so I want us to understand. Understanding numpy array. Numpy arrays. Yeah, I'm sorry, my screen is on my left, and my camera is on my right, so that explains why I have to be switching, you know, to see you guys. So now I have this. The first part of understanding it is how do we create an array? When we have created it, how do we use it? I'm going to take us back a little to some of the things that we did in the past. We discussed something on a list, different types of list. So to create an array, the first way of doing this is to take it from a list. That is, use your list to generate an array. I can say numbers. Let's say num dimeji, num 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 anything, num list equals, remember we did something like this, list of numbers. That is my list. Now if I need to perform some operations around this list easily with some other list and the rest, instead of doing them one after the other, I will have to use Numpy. Now I want to turn this to an array. Let me call it ARR list or ARR1. Let's call it ARR. Now for us to turn this to an array, now we'll do NP. Remember we have said our numpy is an array. I mean our numpy is being represented by NP. I'll say np.array. Then I have my list inside this whole list inside it. That is one way of defining my array. So if I say AR1, that's my array. That is my array. I hope that is understood. Now the next thing, or the second way of building your array or creating your array is using using list. I want to put it somewhere. Let's put it at the top here. Create array using lists. So this is number one method. Let's make this a markdown. Can we, okay, let's make it bold. Okay. Now the second way of doing that, of creating your array, is by using built-in functions. Built-in functions. Let's make this to be bold also. That's method 2. This whole array stuff sounds theoretical, but I don't want us to look at it from that angle. You will see how we shall be applying all this to practical situations. Now, when we talk of built-in arrays, I can say arrays of zeros. That's NP, I can say zeros. Zeros. Yeah. And how do I define it? All I need to do is to give it the same definition, just like I have zeros, zeros, something like that. Something like that is my, you can define it that way. You can also do, as you can see, it's task. So you can also do, let me just copy this and paste it here. You can do once, just in case you have array of 1 1 1 1 1. I'm just using all this as examples, so it's not as if so let's say you have 1 1, what do you call it, 1 1 figure in each, not 1 1 as in numbers, but 1 1 figure. It could be anything, so I'm just using this as examples. So this is 3, this is 3, this is, so what I'm saying here is this. Let me put a comment here. I hope you are getting this. This is how do I call it? Oh, let me use numbers. Let's do zeros, something of this nature. Now here we have 3 from this tree by 4 array of zeros. So what that means is that we have something like I want to open my paint. I need to open paint. I need to explain this very well. My paint is loading. Okay, yeah, this is my paint here. Now I need to. So what I'm saying is 3 by 4 arrays means you have something like a 0, another 0, another 0, another 0. You have 0 here, you have 0 here. 3 by 4 means 3 rows and 4 columns. Yeah, something of this nature. This is a 3 by 4 array. This is row 1, this is row 2, this is row 3. So if we put this together, this is our array. Now we can do array of ones. Let me minimize this. So that's what we have here. Can you see that? 3 rows, 1, 2, 3, 4 columns. Now if I do arrays 3 by 3, that means I'm saying that means I'm talking about having 1, 1, 1, 1, 1, 3 columns, 3 rows and 3 columns. So let me do, yeah, let's have 3, it's fine. So this is 3 by 3 array of ones, 1, 1, 1, that way, in that order. So if I run this now, it gives me this. So we have np.ones. That means I need 1 in 3 on 3 rows and 3 columns, forming an array. This is what we have here now. As you can see now that when you talk of array, you have more than one list. This is like a list on its own. This is like another list on its own. So when you have list inside list, then you are talking more or less about arrays. Now the next thing I want to mention while we are still talking about inbuilt is arrange. np.arrange. np.arrange. Now with np.arrange, what that means is that the arrange is 1R. No, what that means is that we are talking about a range of numbers, not arrange as in the arrange that you know with double R. So if I have, let's say I have 9 here, it's 9 not too much. Let's say I have 3 here, comma, I have 10, then I have maybe 2. Let's do 4. Now if I run this, so what we are saying is that we want to find a range of numbers. Range. Don't forget, range means the difference between the minimum and the maximum. So in this situation, we are talking of array with a range of numbers. Let me put a note here. Array with a range of numbers. Yeah. Then another One here is line space, I think. Yeah, line space. Line space. So with line space, let's assume we have 2, 4, say 7. Now if I run this, we are talking of array with evenly spaced numbers. What the system will do is to give you an array with the numbers evenly spaced. So if you look at this, this is one number, this is another one, this is another one, 1, 2, 3, 4, 5, 6, 7, which is this. The number is starting with 2 and it's ending with 4, but evenly spaced in 7 places. You do not need to cram this. When you need to make use of it, it is easy. You can always reference it wherever you must have kept it, kind of. So it's up to you. Now I move to the next part. Remember during the last part of the session, I think video session 4, we considered data types. So the same way here, so we can have data types just the way we had it on, I mean, in our last video, which is defined. Nothing, it's not changing anything. Now, in this case, just like as we had, we have integers, we have float, we have bool for boolean, depending on what you want to, depending on your interest. So whatever you want to, whichever you want to use those data types determines which of the which of the operations to perform. So my expectations here include you just understanding how to make use of this, what this means. This is not all. We have quite a large number of them. Now I'm going to the next parts. We are still at the introductory part of it, so you have better understanding as we get along. I want to talk about this next part. I'm going to call this array indexing. Yeah, we've done something similar to this under list, indexing and slicing. So I'm going to make this a markdown. Cool. So here we are going to do some of those things that we did on list. So I'm not going to take much time on it. The first thing is, how do we access the element of an array? We have said that you can form your array, and your arrays can be formed from your list. So we don't need to flog list. We've considered list in video 4. If you're not part of that session, please just go back and try to understand what lists are in video 4 of 20. Now, talking about basic indexing, how do we do basic indexing on array? Now let me just do arr2. Let's do 2 now, equal to, remember this is my variable name, we've considered that, equals numpy array. Now with my numpy array, maybe I should just lift what we had before. Let me just take this guy. Okay, let's take 10, 20, 30. 10, 20, 30, 40, 50. Yeah, so this is my array. Now the question is, how do we print what we have here? It's the same way we treated list. Now if I leave this as my array and I want to print the elements one by, I want to access 10, for example. Remember we mentioned that 10 is what? 10 is 0, 20 is 1, 30 is 2, 3, then this is 4. And we said that the last one is the total number minus 1. So it is the same operation, nothing is changing. Now I'm going to print this, print let me do something. Array 2, array 2, let's do 1. Can you see that? 1 is 20. So you can either use it directly this way, or you use print. Print, put this inside the print function. Use the same inside the print function. The answer is the same. So whichever way you are fine. So I'm not going to flog this also, because remember we treated it under our list. Now slicing array also is the same way we sliced lists, so there is nothing much different here. It's the same operation. Let's say we want this is 1 and this is 2. We want only these two, so this is 1 and 2. So let's see, ARR2, that's this name, ARR2. Then I'll put into the bracket here, and I'll tell the system give me 1 and give me 2. You know why we got that? Oh, sorry, this is supposed to be 3. So I have our 20 and 30. Don't forget the last part of your list. Whatever you are expecting, the last part of your list is the total number minus 1. So if I decide to write this as, this is 0, this is 1, this is 2. 0, 1, 2. But if I take out all this is the last one. So that means this is T2 minus 1, which is 1. So the answer here will give me 20. So if I do this, I should have 20. I'm talking about the same thing. Just same thing. Okay, now let's go to something a bit, it's still the same thing but a bit much more involving. Let's have a matrix. I'm going back to our matrix. Where is my paint? Let's assume we have 2, 3, 0. Let's have 7, 2, 1, 0, 5, 9. This is a 3 by 3 matrix, 3 rows and 3 columns. So I have a 3 by 3 here. Now I want to put this inside. I want to call this an array. I want to represent this using Python. So what I'm going to do is, let me minimize it. Let's divide the screen into 2 so that we can see it. We can all see it easily. Let me put this one here so that we're okay. So let me put this one here. I'm splitting my screen. Okay, so this is the matrix that I just put up. Now I want to represent it using an array. So what I'm going to do is I'll come here and tell the system what name do I give this. ARR maybe 3 equal to. Now to represent this as an array, I have to split this. This is one list, this is another list, and this is another list. So what that means is I go back to my code and say my numpy dot array, open a bracket and keep it, then drop all this into that bracket. The first one is 20230. So I open, remember there is a larger square bracket and there's a smaller one. The larger one encompasses everything. The larger one here is just like this one. So this small one now, I want to open another one. So this is 2, 3, 0. That is, let's keep space. Now put a comma here. Then the second one is 7, 2, 1. 7, 2, 1. The next list is 0, 5, 9. That is it. So we are done with our array. We can print it. All you need to do is just call it array 3. That's it. That is it. I hope that is understood. Now, the next thing we want to do, since we have gotten some ideas there on what happens, is we want to do operations around arrays. So I'm going to call that array operations. Array operations. Yeah, it sounds so boring. I remember when I was way back in school also, I never liked it, but it was when I started applying it I discovered that it's not something we can wish away. It's not something we can just say we don't want to do. Okay, so now on list, we did not sum list, we did not subtract list. Array allows you to do all those summation. Now I have an array A equal to no, let me do ARR4 equal to numpy dot array. I want to do summation. This is element wise. Let's assume we have 2, 7, 5, something of this nature. Okay, so we have that. Let's have ARR5 equals, let me copy the same, I'll just change the numbers inside. Let's make this 10, let's make this 2, and let's make this minus 1. So we have the two arrays. Now we can add them together element wise because this has 3 and this has 3. Element wise means 2 plus 10 is 12, 7 plus 2 is 9, 5 plus minus 1 is 4. The same way you can subtract, you can multiply them element wise. So adding the two arrays, adding them, the arrays ARR4 and ARR5 gives us they just pick them directly. The funny thing about this thing is that you can give the summation another variable name. You can say ARR6 equals this. ARR6 equals 4 plus 5. So you can call ARR6 straight away. It gives you an answer. That's it. Adding them up element wise. This is 12, this is 9, this is 4. And if you want to multiply them also, you can say another variable, maybe 7, is equal to ARR4 multiplied by ARR5. So call this guy. That's it. 2 multiplied by 10 is 20, 7 multiplied by 2 is 14, 5 multiplied by minus 1 is minus 5. That's it. That is it. So that's a way of handling such operations. There are other ways, there are advanced ways of doing some bigger stuff than this, but we are not going into all those at this time. So what we want to do is to do the concept of what a data analyst or a data scientist will require, just within the scope of analysis. Okay, so we move to the next one. Now you and I know that we have square root. Just give us some universal functions. Universal functions. They are coming in here because we are using them like arrays. Universal functions. Okay, now if I have say arr8, a new function, which is the same thing as maybe square root of a number somewhere, let's say square root of this one. This is 6, right? Square root of 6. So I'll say square root of arr6. That's it. Do you know why I'm getting that? Because I did not define square root. The system is not aware of what I have typed. You know why? I have not pointed square root to a function. I intentionally did this so that you will understand that if you don't reference the appropriate package or appropriate library, you are likely going to run into trouble. So to correct this now, I bring in my numpy. That I'm saying that square root is coming from numpy. So I need to tell the system. So I put this. We are good. So I can perform that operation. Without numpy, it might be difficult for me to use this function to work. So if I now pick this to run this, since I'm talking about square root of 12, I'm square root of 12, 9, 4. I don't know what that is. Let's see. That is square root of 4 is 2, square root of 3 is, square root of 9 is 3, and square root of 4 is 3 point all this. That's it. That is the way it works. Now the next thing I want to quickly mention is to talk about shape manipulation. That is, how do we use shape? We are going to use most of these things when we start manipulating data, but at that level we'll not be talking about them the way we are doing now. We'll just mention them, apply them, and we're on the go. Now we can reshape array whichever way we want it, depending on our expectation. You can work on your array without shaping it. It's allowed. It's up to you. Your expectation determines the step that you are expected to take. You can have an array that has multiple dimensions, but you want to reshape the whole thing to one dimension or two dimension or three dimensions depending on your expectations. That is when you need to reshape. Shape means give me this set of data this way. That means you are shaping it the way you want it. So we'll just look at that. Then let me call that shape manipulation. Shape manipulation. Okay, now for shape manipulation, the first thing there that I think we need to know is reshaping. Let's assume we have a equals numpy dot array, numpy dot a range. Remember we have considered the range, a range of what, maybe 6, yeah. We now tell the system to say we want to reshape. Remember, array of 6 does not mean number 6. They are talking of array of numbers, array of 6 numbers. So reshape equals let me call it reshaped, because maybe since I want to reshape this, a dot, I'll just call the function reshape, then apply it. Let's see, 2 comma 3. Now I want us to see the difference. I'm going to let's put a down. What is a? Can you see? A is an array of 6 numbers starting from 0 to 5. Remember, the first number is always 0 in terms of index. The index of the first number is 0 also, so we need to note that. Now if I type reshape, you will see what I'm talking about now. Reshape, can you see that? Reshape means these 6 numbers here, instead of presenting them this way, give me in this way 2 rows and 3 columns. Let me give another example. B equals mp dot a range 10. That means I have numbers from 0 to 9. That's 10. Oh, sorry, I left out a here. A range. Now I can reshape it. Reshaped. I don't want to use the word reshaped. Let me call it C. C equals B dot. I want to reshape this one. Instead of giving me, because if I print this, I'm going to have, where is it? B. Where is B, 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 B? I'm going to have this, but I don't want it this way. I want it to be like a matrix. So I need to reshape it. So I'll now say, let me say C is my reshape. C equals reshape. I just want to reshape that guy so that I have something. How do we reshape it? Can we do five along the row? That means 2 rows and 5 columns. Okay, cool. So 2 rows, 5 columns. So to give you, yeah, I always forget I'm using my B. Yeah. Okay, so now if I type my C, can you see 5 rows? 2 rows and 5 columns. 2 rows, 5 columns. So that is a way of using reshape. The way we reshape is similar to the way we flatten. The way we flatten. We call it flatten. Flatten in the sense that you have, say, 200 dimensional figures, which is beyond the scope of what you want to learn anyway, and you want it in 2 dimensions. So we use this kind of thing for such. Okay. Now I move to statistical operations. We can find the mean, the median, the mode of numbers same way. Let me just pop that here also. Statistical, we are going to do a lot of statistical operations. And mathematical operations. We are going to do we are going to make use of a lot of this in the future sessions. Okay, now in this case I'm going to spend a bit of time here, and then I think we should go into our exercises. The first part is aggregation. I want to talk about aggregation function. I'll look at those ones. I'll look at random functions. How do we generate random numbers? Then we'll look at some small algebras. We've done some addition and subtraction, all those things. Yeah, that one shouldn't be an issue. So I'll just give us some of those common things that we're going to make use of as we go in our journey. Because we can't learn everything about Numpy now within this. It's so much. Okay, let me have an array, let's say array 9 equals let's say equals what, mp dot array. Okay, what do we keep inside here now? Let's have 3, 6, 7, 10, 12. This is our array. As you can see, let's check. That's our array. Now we want to sum everything to have a figure. To sum is easy. Just tell the system numpy dot sum. This is what I was saying earlier, that numpy is good, it's beautiful if we know it. So we want to sum everything inside this array, all the elements. Put it inside and you have your answer. The same way you can make it a variable, place a variable here. Let's say we have array 10 equal to that, then call the variable name here array 10. Same way. So it depends on what you want to accomplish. Now I want to find the mean of this. We're going to find a lot of means in all this our analysis thing. We want to find the mean, the standard deviation of these numbers. So for mean, I'll do let's say mp dot mean. Then I'm taking the mean of all this, that is array 9. What's the answer? That's a 7.6. I want to find the standard deviation, mp standard deviation for what? Array 9. That's it. So you can say that is easier, faster than you start calculating, doing all those normal calculations and the rest. It will take you a long time to make happen. Now let's do, let me just give us the last example here, which is mathematical in nature. I want to create some random numbers. We've done the part of it at the beginning, but this time around I want to use rand. Now I'm going to say maybe array 11. Let's call that array 11 equals mp dot array. That is what we would have done normally, but we are not doing that here. Oh, sorry, this is mp dot, because I want random number, random dot rand. Let's say we have 3, 4, enter. So what is ARR1? That's it. Just give me any random number. That's the meaning. Any random number with 3 rows and 4 columns. 3 rows, this is row 1, row 2, and row 3. So anytime you use rand of this nature, it gives you numbers less than 1 by default. Okay. Now the next thing has to do with our files. How do we work within the files? We can consider this here, and we may decide to consider it when we get to pandas. It's the same environment. So whichever way we look at it from, we are still going to make use of numpy. Even on pandas, we are going to make use of numpy. When we use matplotlib and other visualization tools, we are going to make use of numpy. So numpy is key to a lot of other deliverables on Python. So this ends the first part of what we need to do on numpy. Now let's take some quick examples to run with. I put some questions here which I think you can quickly just rub minds with, just to give us a better understanding. So my scenarios, scenario one, scenario one, let's see. Okay, so now for the first scenario, I have the question here. I have put them down already, so to save our time. This scenario is around, let me make this to be bold. Then let's make this, let's give it a title. You have a data set of daily sales, so it's sales data analysis. Sales data analysis. Okay, cool. So that's our scenario one, and this is the problem that we want to solve. You have a data set of daily sales across multiple channels, multiple regions for the past 10 years. The sales data is stored in two-dimensional array. This is the meaning of 2D. Two-dimensional array where each row represents a region, and where each row represents a region and each column represents a day. Your task is to calculate the total sales for each region and identify the region with the highest sales. That is the question. So we have been provided with some sales data, and we were made to understand that for every region we have region 1, 2, 3 up to the last region here. There are three regions here, 1, 2, and 3, and the data set is across um, three 5 days, 5 different data points for each region. So we want to use that to do some manipulations. What we are saying is region 1 has day 1 to day 5 records. Region 2 has something similar. Region 3 has something similar. So we now want to have holistic nature of the whole stuff. Now, so let's see, let me just assume here, the data sets are maybe region 1. Just want to juggle data. Region 1 has just all this. The data set for region 1 is this, yeah. The sales, yeah, for 5 days. For region 2, let me just copy this. Region 2, let's change this to 300. Let's change this to 210. Let's change this to 180. Let's change this to 159, and let this be 320. Now region 3 and region 3. Let's have 150. Just want to have done something different. 179. Let's do 160 here. Then for this one, let's do 182. And for this one, let's do 190. Yes, so we have the data for 5 days in each of the regions. So the question is to calculate the total sales for each region and identify the region with the highest sales. That's it. You will recall that if you are to do this manually, you start punching. Oh, for each region, you can sum all this, sum all this, sum them differently. At the end of the day, you now start calculating, trying to find the highest score, which is the highest amongst them. Now, for me, if I'm to use Python to do this, it's just a 3 lines. I mean, 2 lines of code, and we are there. But the only part that will take us a bit of time is to make it an array. So the solution is as follows. I'll first turn the whole thing to an array. Sales data equals MP. So I'm converting the whole thing to array. Dot array. I'll open this. Then remember our list inside list. Yes. I'll now put the whole thing inside here. I'll copy this first one. No, it's not bracket, it's square bracket now. So I'll come here, square bracket, keep them all inside, comma. The second one, same way. The third one, same way. Oh, this is 3. The third one, same way. Yes, I've converted the whole into an array. So if I run this now, if I call this, it has now turned to an array. That's it. Now, to do what the question wants us to do, to solve the problem, to calculate the total sales for each region, instead of doing the calculation one by one, region sales, let me just call it region sales. I'll just do equal to NP. In other words, total sales for this region, for region 1 up to the third region. All I need to do is to tell the system sum. And what are you summing? Sales data. How do you want to sum? What we are talking about each region. So axis cost 1. So if I pick this now, I think I should have my answer. That's the sales for each region. Easy. Now, which region has the highest sales? I will call the maximum function. Region with higher sales equals, all I need to do is to do what? Call my MP also. MP, there is something called argument max, argmax. Use that, pick this value, this one, and give me the maximum. These are not many, but in case we have something many, it helps us. By me looking at this one, either of this has the highest sales. This is the one that has the highest sales. This one here, region 2. Okay, so I run this. If I pick this guy now, is it 2 or 1? Okay, yeah, region, yeah, it's still this is 1. That's this region here. Region 0 is this, region 1 and region 2. Okay, I hope that is understood. Now we can fine tune our answers by saying, okay, print. Let's print using our f function. Remember our f function. Um, the total sales for each region um, is this. I'll just leave it that way. I'll now go pick the sales per region. This is the sales per region. I'll put it here as a variable. So I'll put it inside this brace. Remember, those of you that were part of the previous session, you understand what I'm trying to say. Now, I want to print the last statement, the one with the highest sales also. Instead of typing, let me just carry all this and paste. Just change the variables. The region with the highest sales is, just do this. Then we can is this. Remember, this guy is coming from a list perspective. It's actually to a human being. This is the second region. This is the first one to a human being. But to the system, this is the 0 row, and this is the first. This is number 1. This is 2. To human being, this is 1, and this is 2. So if you want it to be readable to man, just add 1 to it. That's it. We are done with that question. Now question 2, let me just copy this so that I can use the format. Question 2, I'm in scenario 2. Let me copy the problem. Think I should just pick from here. Scenario 2. So the problem. Okay, your company manages an inventory product. Each product has record reorder level. You have the current stock levels. You need to identify which product needs to be reordered. That is the question. So we have, for each stock we have some stuff, and for each product we have what is called reorder level. Now the question now is, how are we going to arrange ourselves to say these are the things we need to order next and the like. The inventory for each product is being given. So let me just put those ones on the screen. Just copy my the data set is this. Let me put it in the bracket. Put the whole thing in the bracket. So now what I want to do is current level. They all have reorder levels also, and the associated reorder levels are, they give us the values for those ones too. Yeah, this one. for each product. 100 is the reorder level. So we need to solve the problem. It's simple. All we need to do is current stock equals np dot array yeah, we'll drop all this inside. That's the current stock. Yeah, I'm going to use the same cell this time around. Reorder levels equals np, same way, dot array. I just applying those things that we learn. Where is it? So we have them here. Good. Now, in order to identify the product that needs to be reordered, let's now do this. Reorder. Let me use. You can use anything. Reorder status equals. I'll just do np dot where, because I'm placing the condition where what is in stock is lower than what we have here. So the current stock, this one, less than this one. Let me keep space. Less than this one. Finish. So let's see. That's it. This does not need reorder level. That's why there's no zero there. 1, 2, 3. 1 needs, 2 needs, 3 needs, and 4 needs. So index 1, 2, 3. That's fine. So you want to write it the way I wrote the other one. That's fine. It's the same way. Now, the next one has to do with customer segmentation. Let me just pick this. Oh, this is inventory management. Inventory analysis. So this one, let me just paste here. This is customer segmentation. These are small examples that we can make use of. So the question here has to do with, where is it? This one's here. Markdown. This is the problem. You have a data set. This is the data set. Let me grab the data sets. You have a data set. This one is here with customer purchase amounts, and you want to segment customers into 3 categories: low, medium, and high, based on predefined threshold. Of course, the threshold for low is, what do we do? Let's assume it's 100, and 400 for high. Okay, cool. How do we work around this? The first thing you need to do is create the array to put everything inside. So purchase amount equals np dot array go grab these guys and drop them inside. Don't forget this is 0, this is 1, this is 2, 3, 4, 5 in terms of their indexes. Okay, so now the next thing is let's note the thresholds. Low threshold equals 100. High threshold equals 400. Good. These are the things we are provided with. Now to segment them, we need to work around anything from 400 and above is high. Anything 100 and below is low. Then the system should be able to juggle what is medium, because medium was not defined in what was given to us. Now we're going to do that. I'm going to tell the system to pick whatever is in between the high and the low as medium. So let's see. Low spenders. Let's call them spenders. Equals np. That means the indexes with the least here, with low values here. Okay, so where, as you can see, the way I'm applying where purchase amount is less than or equal to the low threshold. That's low. I'll use the same thing to define the high, to define high here, high here. Yeah, that's it. Now we need to define the medium. Let me put medium in between them. Medium. Let me just paste and call this medium. That's this. Now here I want to do two things. Medium is greater than this but less than this. So we're going to say purchase amount is greater than low is greater than low. That is a part of it. And now because we are having two brackets now, let's open a bigger bracket to keep all of them. And purchase amount, let me just pick it here, let me just pick this, less than high. This is high. That's it. We are done. So if you want to see the low spenders, just check this guy. 0, that's this one. You want to see the medium spender, medium spender, oh sorry, I was wondering. Oh, this is medium. Apologies, please. I was supposed to work around that one. I used this one, so no worries. Okay, so for medium spender is bigger than low and is less than high. less than or equal to high. Okay, so for low spender, we are good. That's this first one, and we can see it's less than 100. For medium spenders, those are the ones, medium spenders, 1, 2, 3. This one, and this one, because they are all greater than 100 and less than 400. So the high spenders, that's it. Where is high? High is greater than, oh, it's less than or equal to 400. Is greater than low. Can do greater than low. Use another way here. Yeah, that's it. But if you say greater than low alone, it gives you that value for high. Now, it has to be purchase amount greater than, oh sorry, greater than high, because 400 is the highest, is the threshold. That's it. 5. This one, that's the only one bigger than 400. Now, the next example, employee performance evaluation. Let's quickly look at that. Employee performance evaluation. Okay. Right, so yeah, that's the problem. You have monthly performance scores for a team of employees. Your task is to identify employees who consistently score below a certain threshold in more than 3 months, flagging them for additional training. Can you imagine? This can be something weird to do manually. They've given us all the figures. So we have everything here as this one. The data set. That's it. That's what we have. Yeah. Then the next one. Then the last one. Oh, apologies. This is supposed to be a comma here. This is supposed to be from here. Then this one. Yes. So these were the marks for the 5 of them. They want to see who amongst them perform consistently low for 3 months. So that's the question. Now what do we do? First, drop everything as an array. Performance score. Form an array out of everything. This is what 1, 2, 3, 4, 5. 5 of them. Just put them together. Take this first one, for example. Oh, okay, it's up to here. Put them here. mp.array. That's it. Then drop the second one. Next one. fourth one, and the last one. So that's our array. What happened? Have we left something wrongly somewhere? Yeah, okay, yeah. This, we open this. You are supposed to open a bigger square bracket. Yeah, we're good now. Okay, so let's check. Yeah, that's it. Now, um, we have a threshold. The threshold is, well, is 65. Okay, so I come here and define the threshold equals 65. Cool. So what I need to do is to use the threshold against all these numbers. That is just all we have to do. So below threshold, we want to see those people not performing, equals np dot sum. Performance score yeah is less than threshold. As this equals 1. So how do we identify employees now? The employees to train. Employees to train. Yes, to train equals np where those ones that are below the threshold. So yeah, we have already defined them here, so you just want to display them, kind of. So we want to identify employees that need additional training. So I want to use the where, and the where that we are using is going to be, remember, it's supposed to be against all the employees. This will consider all of them. We only need 3 of them, at least. I mean, what's the question saying? You have the monthly performance scores for a team of employees. You're starting to identify employees who consistently score below a certain threshold in more than 3 months. Okay, 3 or more months. So that's greater than 3 months. More than 3 months. So we don't need equal to there. It's just greater than. Cool. So we are done. Just print this guy. You have the employees 2 and 4, employees 3 and 5. Remember, the first one is 0, so you have 3 and 5. 0, 1, 2, 3. Yeah, this is 5. Remember, the last one is 5 minus 1. Yeah, so these 2 are the 2 employees that we are looking for. These 2 employees. Okay, now the last example for this part That's scenario 5. Let me copy this. I'm just doing all this so that we have practical situations to play around with, because I know it's very rare for you to see a resource where it's been treated this way. This is 5. This I want to talk about financial forecasting. Uh, oh, customer segmentation. No, this is employee performance. This is for employee performance analysis. Okay. Now this last one is around forecasting the profits of an organization. So let me just grab the question. Like I mentioned, I took my time this morning to put these questions in place, but I've not had time to solve them. So that explains why I'm solving them here with you. So we have those things. You are tasked calculating a moving average of quarterly profits over the last 8 quarters to smooth out short-term fluctuation and identify long-term trends. Okay. Um, uh, the past profits are okay. So the first thing is you've been provided the past profits. So just put profit into array. Profits. It's very easy. The moment you drop it into an array, you are done. Array mp dot array. Okay, so let's drop all this. The past profits. Yeah, so need to bring in a square bracket. Go start. Profit equals oh okay, yeah, this is not numbers. Okay, now what do we want to do? We need to define the window size for the moving average. That's what's the window, what's so in this case we've been told um, calculating the moving average 1 2 3 4, they've given you 8 quarters, 8 past quarters. Now the moving average of quarterly, how many quarters do we have in a year? 4 quarters. Okay, so that's for 2 years. Cool. Okay, now we need to define the moving average window. How many months do we have in a quarter? 3 months. So window size is 3. That means it must be 3 profits to have a value for quarterly. So window size equals 3. Then we can calculate our moving average in the sense that this quarter is an average. By the time you add 1 month to it, take another three months, it gives you another average, and the average keeps moving like that. January to January to the end of March is one quarter. It's one average. The moment we get to February, it becomes February, March, April. It's another average. April, May, June, it's another average. June, July, so every 3 months is an average. So that's why they call this moving average. So the moving average average equals MP dot. I'm going to use this function, and the reason why I'm using it is we may not have opportunity of mentioning it later. Convolve. So it's from convolution. Profits. And what are we putting inside? NP dot the window size. Well, you can do NP dot once window size divide by window size. Let me just copy it and paste here. This is supposed to be convolve once here. Okay, yeah. So now the mode equals valid. Yeah, we're going to look at convolve. Maybe we'll find time to look at it at some point. Good, we are good. So what's the moving average? Let's see. That's it. 1600, 1700, 1750, 1800, 1133. So they are good figures that financial officers make use of in their day-to-day activities. So basically we have trashed everything around NumPy to an extent, at least within the scope of data analysis. This this ends all the things that we need to consider at least on NumPy. During the next session, we'll look at something different. Thank you.